Everyone knows the blue whale. It sits at the top of nearly every list about animal size, treated as the definitive answer to the question of how large life can get. 190 tons, 30 meters, the biggest animal ever to exist on Earth. That's the story most people carry around, and most of the time nobody challenges it. But the fossil record has a habit of complicating clean narratives, and over the last 2 decades, paleontology has quietly unearthed evidence of something that forces that claim into genuinely uncertain territory. Not a creature that obviously dwarfs the blue whale, but one that overlaps with it closely enough that the title of largest animal ever may not be as settled as biology textbooks currently suggest. The animal in question is blue whale's ancient challenger, and it goes by the name Ichthyotitan severnensis. Formally described in 2024 from fossil material recovered along the Somerset and Dorset coastline of England, Ichthyotitan was an ichthyosaur, a group of marine reptiles that convergently evolved a body shape remarkably similar to modern dolphins and sharks, despite being entirely unrelated to either. Ichthyosaurs as a group ranged from small, agile predators to genuinely massive ocean-going animals, but Ichthyotitan represents the extreme end of that spectrum in a way that no previously described species had approached. The name itself translates roughly to fish titan, and the fossil material justifies that label more than most paleontological names do. The fossil evidence consists primarily of large jawbone fragments, specifically pieces of the cerangular bone from the lower jaw. Jawbone size in ichthyosaurs correlates predictably with overall body length, and when researchers applied those scaling relationships to the Ichthyotitan material, the numbers that emerged were difficult to process calmly. Length estimates came in around 25 meters, with some analyses suggesting the possibility of individuals reaching beyond that. At 25 meters, Ichthyotitan sits comfortably within the size range of large blue whales. At the upper estimates, it potentially exceeds them in length, though mass comparisons remain harder to pin down given the incompleteness of the fossil material. To understand why this matters beyond simple record chasing, you need to understand what the late Triassic Ocean looked like when Ichthyotitan was alive, approximately 202 million years ago. This was an ocean in the middle of one of the most dramatic ecological reorganizations in Earth's history. The end Triassic mass extinction event was approaching, one of the 5 largest extinction events in the fossil record, and the marine ecosystems of the period were simultaneously rich and increasingly stressed. Ichthyotitan lived right at the edge of that transition, in warm, shallow seas that covered what is now Western Europe, in an environment that was productive enough to support a body requiring thousands of kilograms of food daily, but fragile enough that a relatively modest shift in ocean chemistry would soon restructure it entirely. The mechanics of how an animal reaches 25 meters in a marine environment follow a different logic than gigantism on land. The ocean neutralizes gravitational constraints through buoyancy, which is why the largest animals in Earth's history have all been aquatic. But buoyancy doesn't eliminate every constraint. Thermoregulation, prey availability, and the energetic cost of locomotion all scale with body size in ways that eventually impose limits even in water. Ichthyosaurs solved some of these problems through a body plan that was hydrodynamically efficient, streamlined, with a vertical tail fluke that enabled powerful thrust. But at 25 meters, even an efficient swimmer requires an extraordinary prey base to sustain itself. The late Triassic Ocean provided that prey base in the form of abundant fish and cephalopod populations, but it did so in a context that was about to collapse. Here is the part of Ichthyotitan's story that carries the most weight. It didn't die because it was poorly designed or because a better predator displaced it. It died because the end Triassic extinction event, driven by massive volcanic activity from the Central Atlantic magmatic province, acidified and warmed the oceans rapidly enough that the food web supporting animals at its scale simply disintegrated. The volcanic eruptions that triggered the extinction weren't a brief event. They unfolded over thousands of years, releasing carbon dioxide in quantities large enough to measurably alter ocean chemistry across the globe. For an animal operating at the upper boundary of what marine ecosystems could sustain, that kind of base-level disruption left no margin for survival. The largest animals are always the last ones the ocean can afford to lose, and the first ones it can no longer afford to keep. What the scientific community is still working through is whether the 2024 description of Ichthyotitan represents a single exceptionally large individual or something closer to the typical adult size for the species. Fossil material this large and this old is almost always fragmentary, and scaling relationships, while reliable within ranges, carry uncertainty at the extremes. Researchers have been careful to present their size estimates as ranges rather than fixed numbers, which is the appropriate scientific posture given what the evidence actually supports. Future discoveries along the same English coastline, which has proven unusually productive for late Triassic ichthyosaur material, could either strengthen or revise the current picture significantly. What isn't uncertain is that Ichthyotitan forces a genuine reconsideration of how settled the blue whale's status actually is. The honest answer is that we are comparing a living animal measured directly against a fossil animal reconstructed from fragments, and those two types of evidence are not equivalent. Blue whale measurements are precise. Ichthyotitan estimates are careful extrapolations from incomplete material. That doesn't make them wrong, but it means the comparison carries inherent uncertainty that neither side of the debate should paper over. If you stood at the waterline of a late Triassic European Sea and watched Ichthyotitan pass through the shallows, which it likely did occasionally given that large ichthyosaurs have been associated with near-shore environments, the experience would be difficult to distinguish from watching a blue whale today. Similar length, similar body shape, similar slow power of movement. Two animals separated by 200 million years, shaped by completely independent evolutionary processes into something close to the same solution for the same problem. The ocean keeps finding this answer. The question of which version found it more completely is one the fossil record hasn't fully resolved yet. The blue whale's title may be secure, but it's less secure than it was before 2024, and that uncertainty is exactly the kind that makes the history of life worth paying attention to. The largest animal ever to exist on Earth might be an animal we're still in the process of discovering, preserved in fragments along a coastline that keeps giving up pieces of a story we're only beginning to read correctly.